I was thinking about how we go from the network that CryptoNet Lab was talking about at the beginning. So having on-chain escrow or staked amount of money, and then if I can't directly get my retrieval, I go to this set of third parties, have them attempt to do it, and that if they can't, then that ends up slashing out of that and causes the SP to lose money. And so then there's this question of like, can you push that to something that would work in a CDN context? So one thing you could imagine is in this design, in the initial design, you have that whole process of establishing who these auditors are as an on-chain thing that's relatively slow. And then also you have a pretty heavyweight cryptographic protocol as the way that you're verifying whether that happens, and sort of have a majority thing, and the whole thing's pretty expensive in a number of ways. If you're thinking about what is the economic thing that's happening here, though, a client is trying to get some data and they can't, right? And so the thing that the SP has gained is it has saved the bandwidth cost of that. And so if your fallback is some other trusted third party does trigger at least that much download, then it's better for the SP to just serve the original data than it is for them to have to go into this fallback and serve twice as much bandwidth to two auditors to prove that it actually is willing to serve data, right? Like that alone is more expensive to the SP. It's now wasted twice the bandwidth versus the one to the original client. And so it's in the SP's like economic better interest to just directly serve rather than do that. And so you could imagine doing things like saying, what we'll agree on is like, here's this pool of a few other audit backups. I'm expecting you to be able to serve at least 10 gigs or 10 gigabit per second. And so like I should be able to see from these auditors at least 4 megs per second or some reasonable thing on my individual download. And then whenever a client doesn't see that, it refers back over to the auditors, and the SP has to do it at twice that bandwidth, or it gets in trouble. So you've got a couple then issues, like what if a bad client is just referring everything over to the auditors? Like, are there ways to do that? And so you could imagine at the beginning you agree on a couple things, like potentially you could agree on a fraud rate. And so you say if these auditors are actually seeing that it's all working, most of the time, and it seems like most of these are false reports in that the SP sure seems to be going at quite a bit of, like we're seeing a large fraction of these tokens that have been redeemed or attempts at downloads are getting put over to fraud, but then they're all working. Maybe that causes the auditors to either give some free passes and be like, hey, you seem to be doing this. This seems like a client side at this point that we've identified. And so we can agree and say, we're going to do this fraud test for at most 10%, right? So like we can have a max percentage of the overall amount of downloads that we've agreed upon in this sort of scope of contract that we actually will have the auditors do. Now that's potentially then the SP serves that first 10%, gets good, and then just sort of is like, great, I like won by actually denying all clients or whatever, serving my 10% to the auditor, and we'll call that good. So you need that to still, that percentage needs to be offset by an additional stake for the SP somehow. So the SP is sort of like getting back to a neutral ground, but not getting the upside if it ends up in that. So there's potentially a way where the SP has higher upside by serving to the direct clients, but both by the 2x audit cost and then by potentially only getting back to some baseline in the audit case. The case of a bad client that you made the deal with ends up being sort of like a wash to you as an SP versus a win if you get a good client, is one way that you could think about how that, like there should be enough flexibility in your payment options there. So I'm interested in, can you get down those various costs for that part where you've got a prepayment, an agreed upon set of terms, a pretty lightweight, not fully cryptographic verified, but in terms of the amount of where bandwidth is going to happen, it still ends up incentivizing the correct behavior from everyone. And it seems like there might be something to play with there.
You will not understand anything that's wrong. So our group actually spent a lot of time getting clear on exactly what this network we're talking about even is and what its structure is, because it's actually quite complicated. But first, I actually think a good way to start is to like talk about like what's a CDN, right? So we have like CDN has three parties, right? We got the content owner, the client, and the CDN, right? And this the person sends dollars to the CDN and their content, and then the CDN serves that to the. Where's the trust relationship in this? Does anyone know? Where's the really big trust relationship? Yes, this is a big old T right here, right? Yeah. And if you look at the Saturn design, so this is important to understand when you go into, because when we go to DCDN, the reason it all gets complicated is that we can't just put a big T here, right? So now let's go ahead and go to Saturn, right? So now the trust is still here, but the trust is this guy named the auditor. And what that enables is that the auditor has all of these L1s, right? Okay, and now this person is sending their content to the L1s. I don't know exactly when or how that happens, or even if that's been worked out. And then they are serving it to this. And our L1s here, what this enables is for a bunch of L1s to sign up and serve content. So it's no longer controlled by our super centralized CDN, but there is a centralized auditor. They have full trust. And these guys are like, in the current design, they're big, beefy nodes that have some kind of KYC process, I believe, right? So they're like I'm gonna do like a little semi-trust here, but there's also like a fraud detection, right? Meanwhile, like, one thing to know about this, why doesn't egress work at this end? Because in this link, there is no money, right? So we're going to assume that this link has to be a no money link. So then, now we get into like how this network is theoretically getting to SPs, right? So now there's this whole other thing of like L2, right? And these are random people running a program on their home computer. And the idea is that since there are only, I don't know, 30 of these, maybe, like they're going to not have a lot of content. So they're going to fall back and get them quickly from home computers. That's in and of itself a little bit of a challenging statement. The other thing is we're now moving into the no trust, right? This is like, there's no trust here, right? Also, like, one thing that we identified just in talking about this is why wouldn't they fall back that way, right? Like, yes. And the L2s are regional hubs with, the L2s that they're connected to would be like regional, yeah. No, I know, but I was just thinking if this is we were talking about if this is a big beefy node, right? Like, they might actually get it quicker the other way, and it doesn't really matter. Okay, but let's assume that they can get it quickly from these nodes, right? But they're now totally not trusted. On the upside, we are no longer in the no money. We are now in a money zone, potentially, right? Money can move around between these parties, right? Because there's no expectation it's going to land free. And then finally, these guys, theoretically, are going to fall back to SPs, which are sort of like the L3 of this scenario, right? Though also it's possible that the L1 could just fall back to the SP if like the L2s didn't have it, right? So then the question is, this has all been worked out and it works perfectly for this layer, definitely. So actually, no, it's really awesome like that you guys are at the point of launching this and at least finding out if it works at scale. That's really cool. But then the question is like, how do we deal with this flow, right? Because there's like these two layers, right? And there's a number of problems in it. Like for example, if this person starts getting paid every time they serve a retrieval to the L1, how do we track that, right? So the L1 can report it, but the L1's no longer fully, we could do like a reporting system, like, which is what you guys are doing for the L1, and you could do it all the way up. Like you could basically be like, I report this person serves the retrieval and also sends a report that's like, I got it from SP2, right? And then this guy could go like, you could report up and he could be like, I served a retrieval and I got it from L2 number 3 and they got it from SP number 2. So you have this like chain of like how the retrieval got there. The problem is you've got all these layers of trust and opportunities for collusion along the way. There are a couple of things we could consider, right? First of all, like we could put egress in any of these layers, right? The problem with that is like if the L2 is doing the egress, is paying for egress, that kind of sucks if like my little home node is now all of a sudden sending that it's no longer only deposits, it's getting withdrawals that could potentially go below 0 onto my home node. So that doesn't really work. On the other hand, if the L1 were to fall back directly to the SP, like egress, why wouldn't that work? Why couldn't you just egress to if the L1 falls back directly? Something to consider. The other thing you could do is you could use something like, sort of like the non-chain version of the CryptoNet proposal, which is you could say, as this report comes in, we got from L1, this L1, this L2, and this SP. You could say for 10% of the requests, I'm going to re-execute them, and I'm going to re-execute them in a couple of ways. One is I'm going to try a different L1, but the same L2 same L2 and same SP, right? And then see if that L1 reports that they actually delivered it. I could also try the same L1, but I would say use a different L2 going to the same SP and find out if the SP really delivered it there. And you could also say I would go to the same L1, but use a different same L2 and different SP, or I don't know, yeah. I can't remember which ones matter, but like you could essentially create layers of a referee network that would like, with like say 10% of randomly selected additional requests that you could use to find out if everyone's actually reporting correctly. So yeah, that's the theory. Yeah, you can also, I mean like, and I guess if you misbehave, you could get kicked out. You could get like, depending on how bad the misbehavior is. The biggest, one of the biggest problems in here is these L2s, like they're home computers. You can't do a lot of like, they're very untrusted and like, I don't think you're gonna be able to do a lot of weird money mechanisms with them. Like presumably if I install my, software, my station software on my home computer, I'm expecting it to like have a little counter that slowly goes up of money and never goes down, right? I guess if I'm behaving well, that's fine. Right? That's never going to happen. I don't know. So, yeah. It's not a well-developed system, but it's a system.